Hi, great that you're back for another fun activity with media. Today we want to focus on pixels. We want to create our own graphic filters that we can apply to a photograph of ourselves. So first we need a photograph. We can create one by going to the Costumes tab and selecting the camera here and create a snapshot. But we can also do it with the video feature, so I want to do that today. I can turn on, as you remember, the webcam of my computer with the video capture block from the sensing category. So I'll set the video capture to on, and now I can see my video on the stage. For all of you who have a slower machine, you can also adjust the size of the stage because we're going to do some heavy computing here today, and you might want to create a smaller picture with less pixels if you have a slow machine. To do that, you can adjust the stage size with the settings menu here. So if you go to stage size, you can set the stage to something smaller, for example 240 to 200 if you want. And then you will get a smaller image with less pixels. As my machine works kind of okay, I will keep it like that. Okay. So let's turn the video capture on again. Why does this not work? Okay, we are back live. Now we want to create a snapshot. As you remember, you can create snapshots with the video block here. I can select snap, and I can take a snap on myself, which is that turtle sprite, but I can also take a snap of the stage. If I do that, I can store that, I get an image, and I can store that image to a variable, which I will now create and call my photo. So I can set my photo to a snapshot. Let's try that. Now you can see that on the variable watcher on the stage, you can see the photo that I just took. I can now work with that photo. So for example, I can explore its pixels. Let me turn off the video camera again. And let me switch to the costume that we just took. So I can switch to the costume of my photo. That's the picture I took. And now we can explore stuff in that picture. So for example, we can go to the looks category and pick the width off block. As an input, we want to use our photo that we just took. And we can now find out again how wide that photo is. It's 480 because it's the full stage size, but we can also find out other things, for example, the pixels of our costume or of our photo. If you take the default stage size, you get 172,800 pixels. That's 480 times 360. As you remember, the pixels work with the RGBA color system. So we have different channels in each pixel. The red R, green G, blue B, and the alpha channel that regulates the transparency of a pixel. Let's pick one pixel of our photo so we can examine that a little closer. I'll create another variable that I will call my pixel, and we will just set my pixel to the first item of all of our pixels, so we just have one. As you remember, we can access items of a list with the item off block. So if I set my pixel to the first item of all my pixels, I get the first pixel, and that's a list with 4 elements, again RGB and the alpha channel. Our first graphic effect, or for our first graphic effect, we want to swap the color channels. So our new pixel should have, for example, the red channel in the second channel, so that it's the blue channel later on. The blue should be in the green and the green in the red one. Let's create a block for that. I go to make a block. This is going to be a reporter because it's going to take a pixel list as an input, and it's going to give back or report back another list for one pixel. Our original pixel is going to have RGBA, and we want to change that into, let's do GBRA. The pixel is going to be an input. By the way, if you want to specify what kind of input you want, you can click on that small arrow head here, and then you get the long input dialog. And here I can select what kind of input I want. So for example, I know that my pixel is going to be a list, so I can specify that the pixel input should be a list. And when I go to the block, you can now see that if I click OK here and I click Apply here, I get a list input slot for my block. So this is going to take my pixel as an input, and it should convert the values of this pixel to GBRA. So we want to report back another list. This is going to have 255 alpha in the last channel because we don't want to change something here. And then we have the three elements, R, which was originally the first element of the list, B, which was originally the second, and G, which was originally the third. And now I want to take all those elements of the pixel and rearrange them in that new list that this block is going to report. So the first item, R, should be the third item in our new list. The second item, G, should be the first item. And the third item, blue, should be the second item. Let's try that out. Here you can see our original pixel. And if I apply that now, let's try it again. I get the new pixel and it has 33, 39, 21, which is different than the 21, 33, 39 that we had here. So now we swapped all the color channels. You already heard about the superpowers that map gives you. You can apply a function, which we just made here, on a whole list of data. We also have a list of data, which is all the pixels of our costume. So let's try mapping this RGBA to GBRA function over all of our pixels. I'll get the map block, and I want to do that. And I want to do it, as you remember, map takes an empty, or has an empty input slot in which the respective item that we're just looking at of the input list is filled into, and then the result is reported back to the new list. So let's try that. Wait, let me keep the original list first. So that's our original list or table. And now let's apply this function to our table. And as you can see, the color channels are swapped in each pixel. So we already looked at the first one because that was what we had stored in our pixel. But it also worked for the second one when you compare these, and the third, and we just assumed it worked for all of them. Now we can show that picture again by just using it as an input to the switch to costume block. So let me grab one of these and let's show that picture. As you can see now, my beforehand red face turned to blue because I switched all the red color channels to blue. Everything that was green here before, the green screen in our video studio, is now red. What happens if I do that again? So I can duplicate that, and I can use the result that I get here as an input to another switching block. Let's try that. You can see it also takes quite a while for my computer because I'm computing everything twice now. What we did now is we converted the color channels twice. So we swapped every color channel 2 times. Let's try it a third time. I wonder what happens. Ooh. Actually, I get the original picture back because, as you recall, we have 3 color channels, so if I swap them 3 times, I get the original image back. Let's try another effect. So that was our first one, we call it color swapping. The second one I want to show you is how to create a negative. Negatives are something that you might know still from analog cameras, but you can also create a negative effect by or for digital images. It's pretty easy. You just invert the colors. You remember your color channels, or the values for your color channel, range between 0, which is the minimum value, and 255, which is the maximum value. To invert a color, you just take the value that you have and subtract it from 255. Let's do that. We won't make a block for that. We will just do it directly in the map block. So let's do that with map. Our map block is taking a list as an input here, and our new list is going to have 255 in the last channel, which is alpha. And for all the other ones, we want to take the values that were in there, but subtract them from 255. 255 minus the first value that we had in the red channel, 255 minus the second value that we had in the green channel, and 255 minus the third value of the blue channel. Again, we want to map that over the pixels of the photo. And let's directly switch to that costume. So what we expect now is all the colors inverted. As you can see, it worked, and it's kind of interesting because everything that was dark before now gets bright. Everything that was bright before now gets darker. Also, you invert the colors. The last effect I wanted to show you today is called posturize. Right now, we use the pixels of for all the effects we did until now, we used the existing pixels and exchanged something in them. What we want to do now is we want to exchange all the pixels of our photo with just 3 color values. Red, or let's do red, yellow, and blue. I will remove all of that so we have a clear screen again. And I will also hide my photo and my pixel here. And let's switch back to the original photo. Now we want to use map again. As I mentioned, we want to find out, or we want to separate our image in just 3 different values. We can differentiate between the pixels differently. So for example, we could check out how bright every pixel is and then define a threshold for its brightness. Or we could just take a look at the green channel and find out the amount of green that our pixel has, and then exchange the pixels based on the greenness of the pixel. So for that, we want to take an if statement into our ring here. If the amount of greenness in our pixel that we're looking at is above a given threshold, we want to report a color. So if our green channel, which is the second item of a pixel, is greater than, let's try, so 255 again is the maximum value, 0 is the lowest value. Let's try 200. Then we want to report a color. The color we want to report is, so those are the very green pixels. We can make them yellow. So we want to report back a pixel that is yellow. Yellow means 255 in the red channel, 255 in the green channel, 0 in the blue channel, and 255 in the alpha channel. If our value is not greater than 200, but it's greater than, for example, 100, we want to report red. Red is 0 in the green channel, 0 in the blue channel, and some value in the red channel. Let's try maybe 180. So that's a intermediately dark red. If this is also not true and our value or our green value is below even 100, we want to report blue. To report blue, we can report a pixel with 0 in the red color channel, 0 in the green color channel, and some value in the blue color channel. Let's try, I don't know, maybe 200 here. And again, we want to do that over, we want to map that over the pixels of our photo. Let's check this out and see what happens. Let's see what happens to the data first. If we check that list now, we only have 3 different colors. So all those pixels here will, if I show that picture, be blue. See what else we got. So here, for example, we had a different one. These pixels will be red. We might also find some of the yellow ones. Let's check it out with the show picture block, or with the switch to costume block. As you can see, everything that was green before, like the green screen, is now yellow. My face is red, and my glasses and everything that was pretty dark before and had a low green value is blue. Let's tweak the values a little bit maybe. So I want a little more yellow maybe. So let's decrease that threshold. Also, I want a little more red maybe. And let's try it again. Yeah, that's pretty cool. You can, for example, now export that image if you want to put it up somewhere as an image on your living room wall, or you can try different things with it. So that was the last effect I wanted to show you, and now I wanted to explain or wanted to share what I came up with to put that up also in the physical world. Here's a little project I made. I forgot how it works. Okay, I think I have to press the right arrow to start it. So this is a picture of me this morning in one of our offices, and this is what I did with it. That's the effect we just used, but not with colors, but I just distinguished between maximum, or I calculated the brightness of a pixel, and if the pixel was bright, I reported back white. If it was intermediately bright, I reported back gray. And if it was a dark pixel, I reported back black. That's nothing new so far. Then I used one of Jens's project, which he called dithering, and I used the photo that I just created as an input to that project. As you can see, it's kind of difficult to see my face when you're pretty close, but when you zoom out, the further you zoom out, the better you can see the actual photo. And then I transferred that to Turtle Stitch. I don't know if you already heard of Turtle Stitch. For those who haven't, I will explain it. It's a version of Snap, or it uses Snap as its backbone, and it has the absolutely awesome feature that it can export files for embroidery machines. So here I recreated the image that I've just shown you, and then I exported it to embroider it on a bag. Here's me this morning while I'm trying to embroider it, and you can already see the glasses, my glasses, here's my mouth, and now I can proudly share the result. This is the bag that I did this morning, and you can do something like that with your images as well. You can, for example, create your own merchandise or a present for your mom for Mother's Day, so you can carry you around all day. Thanks for watching the video. Now you can come up with your own ideas. And I have to go somewhere with my new bag. Thanks!